Okay, so let me find this. Okay, here is the practice exam that I'm going to post. And so I'm just going to go through very briefly and just because the work is shown to the right hand side in blue ink, and it's on the Word document or the PDF that I'm going to share as well with this video online so you can see it. But at the very top, I want to remind y'all, don't forget the concepts. I only have 10 math problems here, and these are just examples of what you might see for math short answer or for math multiple choice, but you could definitely have, you definitely will have conceptual questions. And remember, they're going to be in a pool, and so you're not all going to get the same exact question, but I'm going to quiz you over the same concepts. And I'm not using a test bank, so I'm not going to pull these off of questions that you could find on Chegg or Google or anything else like that. So Googling them is not going to help you because they're coming out of my brain. And so there's not going to be like keywords that are going to show up and help you. So I just want to be perfectly transparent about the test as best as I can because I haven't written it quite yet, but I'm working on it this week. So the first question is a titration question. Even if you're not sure, it says that there's a volume of a certain molar KOH. So I wrote basic underneath it. It's titrated. So I'm thinking of lessons 23, lessons 21. Those are the first things that come to my mind. And I am given a strong acid. So I'm like, okay, strong base, strong acid. I can think pH 7 at equivalence volume. Start trying to piece those little concepts together when you're working on these math problems. Now, it tells me that 35 milliliters of the acid has been added, and I want to know what the solution's expected to be. And so I'm starting off with a more concentrated base than acid because 0.25 is more concentrated than 0.15. So what this tells me is when I add 35 milliliters of HCl, that I haven't added enough acid to counteract my base. Because if I have a more concentrated solution, I'm going to have more moles available per milliliter. And so I can tell you that it's going to be basic. Not enough acid yet. So then I can mark out C, D, and E. And then I have to decide, is it before or after the equivalence point? Well, if it's still basic, it's got to be before the equivalence point because that's the definition of a strong base being titrated with a strong acid. It's only going to be acidic after the equivalence point. But if you weren't sure and you wanted to go ahead and do some calculations, you can see I calculated moles of KOH, determined how many moles of HCl that would be, and then used the molarity to calculate the equivalence point volume, which was 58. So that's not enough. I'm almost halfway there, but I need to add at least 23.3 more milliliters of HCl. Okay. So then, given a second one, and this time it's asking me to calculate the pH of this solution. So I'm given a certain volume of HCl, titrated with a strong base, which is more concentrated. And I want to know what the pH is after 40 milliliters has been added. So at this point, I've added, if they were both the same concentration, it would take 35 milliliters to neutralize. But because NaOH is more concentrated, I'm going to have to add less than 35 to get to the equivalence point. And so since I've added 40 in this problem, I could go ahead and mark out A and C because it cannot be acidic anymore and it cannot be neutral. It's got to be a basic pH. To calculate what the pH is, I need to determine, I have my moles of acid that I'm starting with, my moles of base that I've added at this point. I'm going to take the difference between the two and divide by the new total volume. Now when I plug that into the negative log of, I'm actually solving for POH. And so to get to pH, I'm going to subtract that from 14 and get a pH of 12.67. Okay. Second problem is molar solubility. So I'm going to think SSS. It's the molar solubility of magnesium carbonate. So I need to know the magnesium carbonate solid dissociates into magnesium 2 plus CO3 2 minus. It's a 1-to-1 ratio. Remember that anytime we have a 1-to-1 ratio, the KSP is equal to S squared. So since I know the KSP value, it's given, I'm so sorry, I know the molar solubility, I know S, but I don't know KSP. I'm going to plug in my 1.8 times 10 to the negative fourth into my S squared, and that's going to give me my KSP value. No, it's gone. It'll go away. We're sitting outside and Anderson's swimming and there's a hornet flying around. Okay, so then that solves for KSP. Now the fourth problem says that we have the KSP. It wants the molar solubility of silver phosphate. So I have to know here that silver 1, when 1 plus reacts with PO4 3 minus, that's going to make Ag3 PO4, but that's going to be in a 1-to-3 ratio. And so if you think back to the videos, 1-to-3 ratios were always going to be KSP is equal to 27S to the fourth power. If it was 1-to-2, that's going to be equal to 4S cubed. Okay, so now I'm going to plug in my KSP, set that equal to 27S to the fourth power, and I'm going to solve for the S value. Number 5 asks, will a precipitate of magnesium fluoride form when I have a certain amount of magnesium chloride and a certain amount of sodium fluoride? And so in this case, the KSP I'm given is MgF2. If it's asking whether or not a precipitate will form, I'm solving for Q, and I need to study how Q and K are related to each other. So on the right-hand side, you can see I've solved for the number of moles of magnesium from my MgCl2 and divided it by the new volume of the solution, which was 0.8 liters. And then I'm going to do the same thing for fluoride from sodium fluoride to get its molarity. And then I'm going to plug that into my KSP, which I'm going to call Q because I'm solving for non-equilibrium conditions, potentially. And I'm going to plug in the molarities that I solved for above for magnesium and for fluoride. I'm remembering to multiply because it's 2S for fluoride, so it's going to be 2 times the concentration I calculate squared. So I'm going to have to do both of those math functions. And what I'm going to see is that Q is less than K, which means no, a precipitate will not form. In fact, it's going to be difficult to form magnesium fluoride at those concentrations. We did a problem very similar to this, but I think it was with calcium fluoride maybe? I can't remember, but it was in lesson 24, I believe. 24 or 25. So 6 is calculate the hydroxide concentration if we have a pH of 3.45. So when I take the 10 to the minus 3.45, I get hydronium concentration. I then can plug that into Kw, or I can solve for POH in the first place by subtracting the pH from 14 and get POH and take 10 to the negative POH to get the concentration of OH. There's usually going to be more than one way to solve for a problem, not always, but sometimes, and this is a case where there is another way or more than one way to solve for it. There's a hornet right here, go away. Sitting outside has its hazards. Okay, the seventh problem says if the value of Kb is this, calculate the equilibrium constant for the formula below. So the formula below is pyridine when it's acting as an acid, because from left to right it's giving up its proton. So what I really need is Ka for that expression. To do that, I'm going to use Kw equals Ka times Kb, and that's going to give me the Ka value, which I can see is 5.6 times 10 to the negative 6th. Number 8 is a concept question. It says, find the equation that represents Ka2. So this is where, when we talked about polyprotic acids, so H3PO4 has 3 protons to give. When it gives up the first proton in the first formula, that's called Ka1. When it gives up the second one, Ka2, and the third one is Ka3. So when I write all of those out, I see that the second one would be Ka2, and I just identify that in the options given. Number 9 says calculate the concentration of chromate and a certain molar solution of chromic acid, and then it gives you the Ka value, Ka1 and Ka2. Now, in this case, I'm given a starting concentration of chromic acid. So we did, this is the problem where I had y'all go through and calculate the concentration of every species in solution, which seemed like a lot, but I believe, I remember there being an ACS question like this, and I don't remember if it was phosphoric acid or not, but so I set up 2 ice tables. The first one is chromic acid giving up its first proton to form, I can't remember what the first one is that it forms, but it's HCrO4 minus. And I set up that ice table, and I see that it's going to be equal to X. And if I take that X and plug it into my second ice table, really the concentration of the HCrO4, that first conjugate base, is going to be equal to the Ka2 value. And it was true in the one with phosphoric acid as well. The concentration of HPO4 minus was equal to Ka2. So just a weird mathematical thing that happens. And so if you can remember that, it might save you a little bit of time. It won't always be the answer, but if it is, if you can identify that it's the first conjugate base, that it should be equal to Ka2. And if it's the first conjugate acid, it's also equal to Kb1 or Kb2. All right, the last one is a buffer. It's a buffer of ammonia and ammonium chloride, and it wants to know the pH of the buffer, and so we're going to use Henderson-Hasselbalch, the basic form, and that's going to be POH is equal to the negative log of Kb plus log of Hb, right, the Hb plus divided by the B. You have to identify B plus and B. Ammonia is our base, ammonium chloride is the Hb plus. And so because it has equal concentrations, you can make them anything. It can be 10 and 10, 100 and 100, 2,000, 2 million. They're going to reduce down to log equals 1, or log of 1. And so then we solve for everything else, and you get a POH of 4.74. And when you subtract that from pH, you're going to get a pH of 9.26, which makes sense because this is a basic buffer, and so it should have a basic pH to go along with it. All right, so these are just 10 typical problems that have shown up on previous exams, pretty standard. And so go through these, make sure you understand, review your notes if you're unsure, watch Khan Academy YouTube, whatever you have at your disposal to prepare for this test.